Hello everyone, welcome to MBA Karo. I hope you are beating the heat of this summer with our hot series. And if you have already watched the previous two videos, I'm sure you must have enjoyed the videos. Today we have the third class, and today we are going to solve more questions on number system that include questions on remainders, questions on HCF LCM, and questions on base system. So that will in brief cover the number system portion for CAT and other MBA entrance examinations. If you are new to my channel, please don't forget to subscribe to the channel for the best content on all MBA entrance examinations. So this is our schedule. So in case you have just started watching this from the first time, so this is the schedule that we will be having for the 30 days. On all days, you will get one video each. And as you can see that today's topic is going to be on number system. And we already had some questions on number system on the first day as well. So save the schedule and watch the classes accordingly. In case you are preparing for CAT and are looking for a structured preparation source, you can enroll in our CAT batch. Okay, it has live classes which are available as recordings till your course validity, which is till March 31, 2025. So that you appear on other exams also, you have those recordings with you and you can watch the topics for concept building. We have topic wise practice sheets along with the classes. We have a doubt resolution group, and you get full length as well as sectional mock tests. Also, you will be assisted in GDPI for your B school interviews. So we are offering 20% off till 30 June. So you can use the code HOT to get it for 20,000. Okay, and in case you are interested in it, you may enroll in the same. So as the ritual goes, please pause the video, solve the question, and then look at the solution. That is the true way to learn new things. Okay, so in case you are not aware of the concept, then of course you can watch the video and learn something new. In case you know how to solve that question, try to solve it on your own and then look at the solution to see the best approach to solve that particular question. So let's begin with the first question for the day. It says a child was asked to add the first few natural numbers so long his patience permitted. As he stopped, he gave the sum as 719. When the teacher declared the result wrong, the child discovered he had added one number in the sequence twice. What was the number that he added twice? Now, this question is related to the concept of sum of first n natural numbers. And that is given by n plus 1 by 2. Now, the sum is n plus 1 by 2 and the child is reporting the sum as 719. Now, the very first thing is the actual sum should be less than 719. Actual sum will be less because the number is one of the numbers is added twice. So what we will do is we will formulate an equation n plus 1 by 2 is less than 719. Okay, so that gives us n plus 1 is 1438. Now we will do a hit and trial to figure out what could be the value of n. Now if you take 35 square, 35 square is 1225, and if you take 40 square is 1600. So we will have to think of a number between 35 and 40 such that n plus 1 is 1438 is less than 1438. Okay, so let us think of some number. Now 1438 will lie somewhere exactly in between. So maybe we can hit and try with 37 and 38. Okay, so let us put n is equal to 37. 37 into 38. 37 into 8 is 296. 29 carries 100, 1406. Okay, so you can do the calculations. Okay, you will get 1406. Now, is it less than 1438? Yes. What if we take 38 into 39? Okay, how will you get the result? See, if you know this product, now it is 38 into 39. So plus 2 times. So 38 into 2 is 76. And if we add 76, it becomes 1482. So we shall not accept it. So the value of n is 37. So if the question were asked that how many numbers did the child add, so the answer is 37. But the question is different. It says what was the number that he added twice. So his actual sum is n plus 1 by 2. So this is n plus 1. Divide this by 2. Okay, so 1406 divided by 2 is 703. Okay, actual sum is 703. He answered as 719. So he added 16 two times. So that is the answer to this question. Now some of you might be wondering that why did we take just 37? Why not a lower number? Okay, suppose if we take n as 35, because it is saying that it is less than 1438. So if we take 35, n equal to 35, okay, so the sum will be this by 2, this is 18, 18 5 90, 9 carries 54 630. Okay, and we are saying that he reported the answer 719. So the number missed is 89. Now, if he is adding till 35, how can he miss 89? Okay, so that is why we need to take the number which is just less than 1438, the sum which is just less. So we will take the immediate value of n before that. So no lesser value. Okay, so we will take n equal to 37. Actual sum will be 703, and the student missed the number 16. Now we will do another question on the same concept, but in this case, the storyline is different. That does not matter. The thing is, here a number is removed, right? In the previous case, a number was extra. In this case, a number is removed. So it says that one page is torn from a book whose pages are numbered in the usual manner, starting from the first page as 1. The sum of the numbers on the remaining pages is 3, 4, 5, 1. The torn page contains which of the following numbers? Now see this, whenever we have a book, right? So what does it mean that what is the sum of page numbers? Sum of page numbers will be n plus 1 by 2. Again the same concept, sum of first and natural numbers, because it says that starting from the first page as 1. So the numbers are added 1, 2, 3, 4. Now sum of page numbers is n plus 1 by 2. It should be greater than 3, 4, 5, 1 here. Why? Because the reason is, if we take pages are torn, the sum will reduce. So this sum has reduced and has become 3451. So again, like when we simplify it, it becomes, it should be greater than 6902. Okay, now some squares that we should know is 80 square is 6400, 85 square is 7225. This is 6900. So maybe we can go with 83 and 84. Let's check 83 and 84. So if you take n as 83, so 83 into 84, let's do the calculations. Okay. So if you are good at calculations, you can do it directly or you can do it step by step. Since I'm strong, I will do it directly. 84 into 3 is 252 and 25 carries. 84 into 8, 84 into 2, 168. 4 times 336, 672 plus 25 is 697. Okay. So if we take 83, it goes more than this. Okay, now 6972. Now if we take the sum of page numbers as 83, okay, so we are taking that there are 83 pages, so that means the sum is actual sum. Now this is a slightly different question. Actual sum will be 6972 by 2. Why? Because 83 into 84 by 2, so we will get 3486, right? 3486 is given in the sum. Now if you take the remaining sum is 3451, so that means sum of torn pages equals 35. Okay, sum of torn pages is 35. Now there are two torn pages, right? Because you tear a page, it has both faces. Now that would mean, and they are consecutive numbers, so that means the pages are 17 and 18, but they are not given in the options. Okay, so what is the next thing that we can think of is, what if the, now in this case, this is a special question on books. If there is a book, then they can have, like, since in the previous case there was just one number that had to be added, here there are two numbers, two consecutive numbers. So what if we take n is equal to 84? See, if we take n is equal to 82, we will get a lower number. If you take n is equal to 84, then sum is 84 into 85 upon 2. So we'll get 42 into 85. Okay, can be done as, like, you take half of it, 27 and 170. So this will be 17 117, 1 carries 35, 3570. Okay, 3570, and the reported number is 3451. So the difference is 119. Okay, so this is the sum of torn pages. So that means 59 and 60. So that is our answer. Now, if in this question 17 or 18 was given, that is also correct answer. This is also correct answer. The only thing is, since it was not given in the options, that is why we took this number. Okay, so that is the solution to this question. Now let's move on to the next question. This is on remainders. So now the next few questions are going to be on remainders. When 242 is divided by a certain divisor, the remainder obtained is 8. When 698 is divided by the same divisor, the remainder obtained is 9. When the sum of 242 and 698 is divided by the divisor, the remainder obtained is 4. What is the divisor? Okay, so that we need to find out. So we know that a dividend is divisor into quotient plus remainder. That is the format of a number. So you must know this, whether whichever theorem you are applying, this basic principle should be in your mind. So when we take 242, we are using the same divisor. So let us say the divisor is D. Okay, let's say the quotient is A, in this case D into A, plus remainder is 8. Right, now if you take 698, that is divisor will remain D into B plus 9. Okay, when we add these, so we will get 900, and so this is 40 and 940 is equal to, divisor is same. Okay, that is we need to find, let us say the quotient is C plus 17. Okay, so that is what it gives. Right, now one way is this. Now if you see this, it gives us the D into A is 234. Okay. D into B is 689, and D into C is 923. So we are dividing, we are multiplying the same number with three different quotients, and we are getting these three numbers. Okay, so it should be a factor of all these three numbers. Okay, D is a, even if we were given just two numbers, we could have got it. So D is a factor of 2, 3, 4, 6, 8, 9, and 923. Okay, so what we can do is, we can divide the larger number and get the factor directly. So we'll find the, basically it is finding the HCF. So 3 times would give us higher. So if we take 2 times, you will get 468, and you will get 221. So 221 you divide 234, we get 1 times. So this is 13. Now with 13, if you divide 234, it is 18 times. Right, so we get D as 13. Okay, now if it is like, see, if we are taking DA, D is 13. So if we take 13A plus 8, and if we add 13B plus 9, so what we will get, 13 times of A plus B plus 17. Now 13 is divisible by 13. So we can say 13A plus B plus 13 plus 4. So 13 times of, that is just a verification step, right? You just need to find this. So it satisfies that remainder is 4. So you just need to find D by taking factors of the HCF of these three numbers. Okay, so even if you take the HCF of 2, this was just to verify the answer. Okay, so the answer is 13. That you divide by 13, it will give you remainder 8 in the first case, 9 in the second case, and when you add, you get the remainder as 4. What is the remainder when 16 factorial minus 15 factorial minus 14 factorial is divided by 17? Now this is a theorem this is a question which is based on Wilson theorem. Okay, Wilson's remainder theorem. Now Wilson's theorem says that for a prime number p, okay, if the prime number is p, then p minus 1 mod p minus 1 factorial mod p is equal to p minus 1. Okay, p minus 2 factorial mod p is equal to 1, and p minus 3 factorial mod p is equal to p minus 1 upon 2, where p is a prime number. Mod means the remainder when you divide the number by divide a number by the given number. Okay, so here we will put p is equal to 17. So 16 factorial divided by 17 will give the remainder as 16. 15 factorial divided by 17 will give the remainder as 1. 14 factorial divided by 17 will give the remainder as 8, half of this. Okay, so you get the remainder as 8 in this scenario. Now, this remainder is 16 minus 1 minus 8. 16 minus 9, we get 7 as the answer. So, this is a direct application of Wilson remainder theorem. Let's look at the next question on theorems, and this theorem uses Fermat theorem. Okay, this question uses Fermat theorem to solve the question. So it says, what is the remainder when 7 to the power 50 is divided by 90? Okay, so let's see this question. 7 to the power 50 divided by 90. So first of all, we will find the Euler number of 90. Okay. Euler number of a number is given by n into 1 upon 1 minus 1 upon a. Okay. 1 minus 1 upon b, 1 minus 1 upon c, and so on, like 1 upon b, c, d, any number, where a, b, c, and so on are prime factors of n. Okay, so if you talk about 90, 90 is what? 9 into 10, 9 is 3 square, 10 is 2 into 5. So the prime factors are 2, 3 and 5. So we will have these three prime numbers. Okay. So if you look at this n, okay, n is 90. So we'll find the Euler number. First I'll tell you how to find the Euler number, and then I'll tell you the significance of Euler number. So 90 into 1 minus 1 upon 2 into 1 minus 1 upon 3 into 1 minus 1 upon 5. So what do we get? 90 into half into 2 by 3 into 4 by 5. Okay, so this gets cancelled. 15 into 6 is 90. So 6 into 4 is 24. Now what is the significance of Euler number? This is called Euler number. And this theorem is called Fermat's theorem. So we are revising each of the theorems of remainders in this video. So if you are enjoying it, please don't forget to like this video and recommend our channel to fellow CAT aspirants. So Fermat's theorem says that if there is a number a raised to the power e upon b, the remainder is 1. Where a and b are co-primes, okay, and e is Euler number of b. Okay, so that is the criteria here. So we have 7 to the power 50. So we have Euler number of 90 as 24. So any number n raised to the power 24 by 90 will give the remainder as 1. Okay. So 7 to the power 24 by 90 will give the remainder as 1. So that means power of it, if you take square of this, so that becomes 7 ki power 48 by 90 will give the remainder as 1. Okay. Now it is 7 to the power 50. So 7 to the power 48 into 7 square mod 90. Mod means the remainder. Okay. So 7 to the power 48 by 90 gives the remainder 1, and this is 49. So the remainder is 49 in this scenario. So that is the answer to this. So this is an application of Fermat theorem. So Wilson theorem, Fermat theorem, and Chinese remainder theorems are three important theorems in remainders. So I hope you are enjoying this session thus far. So please don't forget to like this video and subscribe to our channel if you have not yet already. Find the smallest number that leaves a remainder of 2 when divided by 5, 3 when divided by 7, and 10 when divided by 11. Now this is called Chinese remainder theorem. Okay, so how do we solve this question is number that leaves remainder of 2 when divided by 5. So we will take two pieces together and the third piece later on. So 2 when divided by 5. So we have 2, 7, 12, 17, and so on. Produce a list like this. Okay. 3 when divided by 7. So we have 3, 10, 17, 24, and so on. Okay. So this is N1, N2, and N3. N3 we'll find later. Now in N1 and N2, find the common entity. The common entity is 17. Okay, first thing is we will find the, now we can break it into a simpler version, that find the remainder of a number which when divide 2 divided by 2 when divided by 5, 3 when divided by 7. So that is the least number. If you are asked about 2, the answer is 17. Okay, but we have to include a number that is giving a remainder of 10 when divided by 11. So what we will do, we take LCM of, what are the dividers? 5 and 7. 5 and 7, that is 35. Okay. So the next thing that we need to do is we will find a series that by adding 35 to it. So 17, 52, 87, 122, and so on. Now N3, we will produce a series and find a number which is common in this series and N3. So 10 when divided by 11. So 11 से 10 होना चाहिए, 10, 21, 32, 43, 54, okay, 65, 76, 87. This is the common number that we get. Okay, so the answer is 87. So in Chinese remainder theorem, what we do is we find one series based on the set of remainders, like 2 when divided by 5. So we write 2, 7, add 5, 5, 5. Similarly, it is 3 when divided by 7. So 3, 10, 17, and so on. Okay. So if the smallest number we have to find, we find the common number. Okay. So that is Chinese remainder theorem for two divisors. Now when a third divisor is included, so what we do is for the first two divisors, we will formulate the LCM and continue this series. And then what we did for first two, we had to find a common one. So generate a series for the third number and find the common one with them. Okay, so as a practice, I would suggest you that treat N1 as this, N2 as this, and then find N3 using this, right? Or try this as the third one. First try with the first and the third one, N1 and N3, and then find the series with N2 and see that if you get the same answer in all the cases. Find the remainder when 2 to the power 29 is divided by 60. So we are solving all varieties of remainder based questions. Now the remainder theorems that we have generally are based on co-primes. Okay. Now 2 to the power 29 by 60. 2 and 60, the power of 2 is common. So first step is we will find what is common in 60. 60 is basically 2 square into 15. Okay, 60 is 2 square into 15. So we will remove the common power. So that will become 2 raised to the power 27 by 15. Okay. Now, first of all, we will find the remainder in this case. Okay. So what is the remainder when 2 to the power 27 is divided by 15? Now see this, 2 to the power 4 is 16. Okay. So 2 to the power 4. So can we say 2 to the power 4 is 16, and if we divide by 15, we get the remainder as 1. So can we say that 2 to the power 4 raised to the power 6 into 2 raised to the power 3 divided by 15? Okay. So what do we get? We get the remainder as 1, because 2 to the power 4 divided by 15, the remainder is 1. 1 raised to the any power is 1 only. 1 into 8. So the remainder is 8. Okay. So when we have 2 to the power 27 mod 15, the remainder is 8. Okay. Now in this question, what we do is, first we take out the common power and then multiply the result with that common power. So we had taken out 2 raised to the power 2. Okay. So now we will multiply it back by 2 raised to the power 2. So we'll multiply it back by 4. So we get the answer as 32. So the answer is 32. If a number leaves a remainder of 4 when divided by 9 and a remainder of 7 when divided by 11, what is the remainder when it is divided by 99? So this again can be done by Chinese remainder theorem. Remainder of 4 when divided by 9. Okay, so what we do, we find the series. Okay, and 4, 13, 22, 31, 40, right, 49, and so on. 7 when divided by 11. 7, 18, 29, 40, and so on. Okay. So the common number that you are getting is 40. So the answer is 40. Okay. So this was a straightforward question. Even if you do not know Chinese remainder theorem for this question, you could have answered by looking at the options. 4 when divided by 9. Okay. So this is divisible by 9. Okay. This is also divisible by 9. This gives a remainder of 6. So one, like, the options made it super simple. So you need to be vigilant with the options also. So there could be some questions, maybe one or two out of the set of 22 questions, which could be easily answered by just looking at the options, even if you are not aware of the concept. Now, most of the CAT aspirants are not aware of this fact, that if you are not aware of the concept, you can still answer some of the questions in quant. It just requires common sense. So we apply Chinese remainder theorem again here. Now you might be wondering that what it has to do with 99. So if you remember in that previous question, we found the remainder using the LCM. So LCM of 9 and 11 is 99. So if we divide by 99, the remainder should be 40. So that is how we answer it. So that was a sitter, not a hot question. Maybe some cool question. Now here's the next one. How many numbers between 3000 and 5000 have exactly 3 factors? Now questions related to the number of factors could be asked, and it was present in CAT 2023 as well. So 3 factors. Now how do we find the number of factors? So if the number is given by a to the power x, b to the power y, c to the power z, and so on, where a, b, c are prime numbers. Okay. So the number of factors is x plus 1, y plus 1, z plus 1, and so on, depending on how many prime factors do you have. So if you have just 2 prime factors, then it will be x plus 1 into y plus 1. Okay. Now we have to find 3 factors. So 3 factors means it should be 2 plus 1. Okay, so 3 is 2 plus 1. You cannot generate 3 to any through any other number. So 3 is 2 plus 1. So that means it means the number should be of the form a square, where a is a prime number. Okay, so the number is a square where a is prime number, right? Now finding some square numbers near it. So 55 square is 3025. Okay. And if you take this is 70 square is 4900. Now some of the students might take the range 55 to 70 and they will count the number as 16, and that is an absolutely wrong answer because a should be a prime number. Okay, so 55 to 70 there are 16 numbers, but we just have to count prime numbers because if a number is not prime it will have more factors. Okay, so only a prime number will have of this format a square. Okay, now we'll find that prime numbers between 50 and 55 and 70. So we have 59 as a prime number, 61 is a prime number, and 67 is a prime number. So we have three such numbers which have exactly three factors that lie between 3000 and 5000. The next question is also on number of factors. It says how many numbers less than 100 have exactly 12 factors. Okay, so now we will have to think of possibilities that how can we generate 12 factors. Okay, so 12 factors could be like basically it can be like, see, we said that it is a plus 1 into b plus 1 into c plus 1, d plus 1, etc. Okay, etc. So let's start with a plus 1. So suppose there is only one prime factor. Okay, so if there is only one prime factor, the number is a plus 1. So that should be 11 plus 1, which is 12. So we can have of the format a raised to the power 11. Okay, now if there are two factors, so think of 12 as a multiple of two numbers. So we can have 2 into 6 is 12, and also 3 into 4 is also 12. Okay. If 2 into 6 is 12, that means 1 plus 1 into 5 plus 1 is 12. And in this case, we have 2 plus 1 into 3 plus 1 is 12. Okay. So it means that like if we have this number as a b to the power 5, this a square into b cube. Okay, why are we taking? Because the power, the number of the power plus 1. So first prime number power is 2, second prime number power is 3. And if you have to take three factors, can we take three factors? So think of 12 as a multiple of three numbers, 2 into 2 into 3. That is how we can write 12 as a factor of multiple of three numbers. So this means 1 plus 1, 1 plus 1, and 2 plus 1. So basically it is A, B, and C square of this format. Now A, B, C, all these are prime numbers. Okay. Now we need to take these uh, numbers. Now if you take b is equal to, let's say, fifth power, so 2 to the power 5 is 32, 3 to the power 5 is 243. Okay, so we cannot take b as 3, so we can take b as 2. If you take b is equal to 2, this is 32, and a we cannot take as 2 because a and b are different prime numbers. So if we take a is equal to 3, that means the product will be 96. So one such number is 96. Now we have to take a square b cube. Okay, 2 cube is 8. Okay, 3 cube is 27. 5 cube is 125. 5. Okay, so that is not permissible. So we will take b can be 2 or 3. So now if if b is 2, so b cube is going to be 8. If a is something, a square निकाल लेते हैं. ठीक है, so we can put a as 2, a square will be 4, isn't it? Oh, sorry, a we cannot take 2 because a has to be a separate number. This is 9, so 8 into 9, the number is 72. Now, if we take a as 5, this will be 25. Product will be greater than 100. Okay, so we will not accept it. Now, we will treat b as 3. So, b cube will be 27. A, if you take 2, so 2 square is 4. This is greater than 100. So, no such other number. So, from this, we have 72 as a number. Now, third case, ABC square. ABC square. Okay. So now C square, we will try to take C small because C square will become large. Now suppose if I take C as 3, okay. So if I take C as 5, let's go with the number. So if I take C as 5, C square will be 25. Okay, 2 and 3 greater than 100. So even if we take the smallest number. Now if I take C as 3, it is 9. We can take 2 and 5. 2 into 5 into 9, 90. Okay, so 90 is one such number. Now, if I take c square as 4, right, instead of going to 9, because if I take any other prime number, let's say if I take 2 into 7 also, it will be greater than 100. So we can take c as 2 and c square as 4. So we will take other prime numbers like 3 and 5. So that is 60. Okay, this is 4, 3 and 7 because 7 is also prime. So 21 into 4, 84. If I take 3 and 11 as the next prime, this is greater than 100. Or if I take 5 and 7, that is also greater than 100. Okay, so that means these are the only three prime numbers of this, sorry, only three numbers of this format. Okay, so this could be a potential CAT question because this year there was a question which said that how many numbers have exactly 4 factors. Okay, and so here we get 5 such numbers. And if they ask what is the smallest number with 12 factors, that is the smallest number with 12 factors. So there are 5 such numbers less than 100 that have exactly 12 factors. Now this is a difficult question and this is the step-by-step process to tackle this problem. I hope you are enjoying this session and it is going to be a fruitful one for you because you are going to learn something new from this. So please don't forget to like this video and subscribe to the channel if you are not a part of this channel. Okay, so here's the next question. It says 4 logs of woods of length 5 1 by 4 meter, 1 13 by 15 meter and 3 1 by 2 meter and 4 9 by 10 meter are cut into small pieces, all of which have equal lengths. Each piece of wood is as long as possible. How many pieces of wood are obtained? So now this is a question. So if you have practiced number system, you know that this is a question that involves HCF. We are cutting woods. So let us understand what does it mean. So we are cutting woods into pieces, okay, all of which have equal length. So each of these pieces is of equal length. So equal length means this number should divide the bigger number. So that means it is a factor. Okay, each piece of wood is as long as possible. So these are the hints. Equal length. So equal length means it is divisible by that number. Divide kar raha hai, and it is as long as possible. So it is highest possible. So that means we have to find HCF of these numbers. Now HCF of fractions is so HCF of these fractions basically it is 21 by 4 and this is 28 by 15 and here we have 7 by 2 and 49 by 10. Okay, so this is the HCF of We have to find HCF of these fractions. Okay. Now HCF is HCF of numerator, okay, upon LCM of denominator. So if we take HCF of these numbers, so we get 7, and LCM of these numbers is 60. So HCF is 7 by 60, right? So that is size of, now if they ask that what is the size of one piece, so one piece is 7 by 60 meter long. Okay. Now if I have to find the number of pieces, so 21 by 4, we will divide by 7 by 60, and this is the number of pieces of this wood, and so on we will do for the remaining pieces. So let us simply do it. 21 by 4 into 60 by 7, because division by a fraction means we multiply with its reciprocal. Okay, plus 28 by 15 into 60 by 7 plus 7 by 2 into 60 by 7 plus 49 by 10 into 60 by 7. Okay, so this is the number of pieces. So we'll just do some calculations. 3 and this is 4, and again this is 4, 30, 7, 7 gets cancelled, 6 and 7. Okay, so add these. So we get the numbers as 45, 16, 30 and 42. Just quickly add these numbers. 58, 88, 88 plus 45, you will get 133 pieces. So that is our answer. So beautiful question on HCF, an application of HCF. So we find the length of each piece. Okay, so length of each piece is the HCF, and then we find how many pieces can be obtained from individual woods and then add them. Okay, so that is 133 pieces. All right, let's look at the next question. It says there are two integers 34041 and 32506. When divided by a three-digit integer n, leave the same remainder. What is the value of n? So this is pretty much similar to one of the questions that we attempted previously. Okay, and let's look at this concept. So 34041 is equal to, let us say it is divided by a number n. So n into x plus there will be a remainder r1. Okay, and we get 32506 is, let us say, m into x plus r2. Okay, so they leave the same remainder. So that is r and r. So when we subtract these, we get n minus m into x is equal to, because r will get cancelled. So this is 1535, right? Now we are dividing by a three-digit integer n. So x, sorry, this is n into x, n into y. Okay, because the quotient is same, that is n into y. So we can say n into x minus y. R will get cancelled. Right. Now this is a three-digit number. Now out of these options, which number divides 1535? If you see, divided by 5 is 307. And in fact, 307 is a prime number. So you will not get any other three-digit number. So the answer to this question is simply 307. So find the difference and take a factor of that number as the answer. So 307 is the right answer. The sum of two non-coprime numbers added to their HCF gives us 77. How many such pairs are possible? And these are some crucial questions of number system that could help you ace CAT, ZAT, etc. Remember, number system is an integral part of ZAT also. So even if you do not get too many questions of number system on CAT, but in ZAT definitely you will have at least 3 to 4 questions on number system. So this series is going to build your concepts on all topics for CAT and other MBA entrance examinations. So two non-coprime numbers. Non-coprime number means, coprime means their HCF is 1. Okay. Non-coprime means their HCF is not 1. Okay. So let us say their HCF is 77. So let us say their HCF is A. So let the numbers be HA and HB, where H is equal to HCF of the numbers. So H of A plus B is equal to 77. Okay, so H of A plus B is 77. So if we take H is equal to, either H will be 11. If we take H is equal to 7, then A plus B is 11. Okay, so that will give us, if H is equal to 7, A plus B is 11. So now these are non-coprime numbers. Okay, so we will have to find the values here. So we can get 1 and 10. Okay, we can get 2 and 9, 3 and, sorry, we need to add, sorry, this is a mistake, which is not H A plus B. We have to add H, because the sum is numbers added to their HCF. So H plus H A plus H of B is 77. So H is common. We get A plus B plus 1 is 77. We have to add the HCF also, not just the numbers. Okay, so we have to add HCF also. So if we take H is equal to 7, then A plus B plus 1 is equal to 11. Now we can take the values of A and B as 1 and 9. Okay. We can't take 2 and 8, because if you take 2 and 8, what will happen is, if you take 2 and 8, that means you take the numbers as 14 and 56. Okay, so what it makes is, you will get the HCF as 14, not 7. Okay, अगर आप 2 और 8 ले लोगे, so basically when we take these A and B, so A and B should be co-primes, वरना HCF डिस्टर्ब हो जाता है. So if you take 2 and 8, that will become, the HCF will not be 7. That becomes 14. Okay. So we will not take 2 and 8. We can take 3 and 7. We cannot take 4 and 6. We cannot take 5 and 5. So two pairs here. If we take H is equal to 11, that means A plus B plus 1 is 7. So A plus B is 6. So we will get 1 and 5. And that is the only pair. We cannot take 2 and 4. Okay, because if you take 2 and 4, then it will become 22 and 44. If you go by this logic that HCF is 11, 2 and 4 if you take, see there HCF is not 11. So we will have only one pair here. So one pair here and two pairs here. So we have three such pairs. If you want to see the numbers are 7 and 63, 21 and 49, and 11 and 55. Their HCF is 7, their HCF is 7, their HCF is 11. Adding, we get 77. So it was a crucial question on HCF and the use of co-prime numbers to get the desired sum. Next question, it's a sitter and it's an application of LCM. Tilak, Suraj and Praveen start running around a circular stadium and complete one round in 12 seconds, 9 seconds and 15 seconds respectively. In how much time will they meet again at the starting point? Okay, so it's a very simple question. Just understand it, like even if you do not understand that it's an application of LCM, let us understand how it needs to be done. So Tilak completes in 12 seconds. So next he will complete in 24 seconds. Next he will complete in 36 seconds, 48 seconds and so on. Okay. Now this person completes in 9, 18, 27. So what we are calculating? We are calculating the multiples. So we need to find LCM of the common multiple, means they will meet again at the starting point. So LCM of 9, 12 and 15. 9 and 12, the LCM is 36 and 5, it is 180. Okay, 90 is not divisible by 12, but 180 is divisible by all three of them. So LCM is 180 seconds. So 180 second means 3 minutes. So they will meet again at the starting point after 3 minutes. So this is a direct application of LCM. So we have seen questions on HCF and LCM and their useful applications, common applications which are often tested in examinations. What is the sum of the digits of the least number which when divided by 5, 6 and 8 leaves the remainder 3 in each case but is exactly divisible by 11? So this is a question on LCM plus it involves Chinese remainder theorem as well. So if the only the first part of the question existed, right? Least number which when divided by 5, 6 and 8 leaves the remainder 3. So if just this part existed, so this number is LCM of 5, 6, 8 plus 3. So what is LCM of 5, 6, 8? 5 and 6, 30. Okay, and then we need to get a multiple of 8 that will make 120 plus 3. Okay, so that is 120, but it is not exactly divisible by 11. No, it is not exactly divisible by 11. So when we include the this part also, so basically we have to find n into LCM of 5, 6, 8 plus 3. If only this part existed, the answer would have been LCM of these three numbers plus that common remainder. Okay, n into LCM of these numbers plus that remainder. Okay, so we will say n into, or we can write 120n plus 3. So we'll take 123 is that first number. Okay, in fact, the first number is 3, because if it is says that it is like 3 is also divisible, it gives the remainder 3 only. Okay, some students make this mistake. So 3 is that smallest number and then 123. Then you can take 243. Okay. Is it divisible by 11? No. Then you take 363. 120, 120 add karte jana. N is equal to 2, n is equal to 3, and so on add karte. So this is 363. Is it divisible by 11? 3 plus 3 is 6. Okay, so it is divisible by 11. We are asking sum of digits. Deliberately ask that sum of digits, because if the number was asked, you could have used options and answered the question. Okay, so the sum of digits is 3 plus 6 plus 3, which is 12. So that's the answer to this question. All right, so let's see the next question. The numbers from 1 to 500 are written in the base 7 system. How many of the numbers will have a non-zero units digit? So let's have a couple of questions on base system also. Although a rare topic, but yes, you may get questions from this topic in CAT or Z. Maybe quite much possible, but very few students cover this topic. So be it any base system, forget base 7 system. So let us say we have a number A, B, C. So the number is given by n to the power 0. So we say that a n cube plus b n square plus c n plus e. So that is the number. Okay, it has more digits. So we start from the right end, then move to the left portion. So this is a number which is the format, right? Now it says if a number is written in base 7, right? So it will be of this format, last digit will be 0. It is saying that non-zero units digit. Okay? If the units digit is 0, okay? If the units digit is 0, what does it mean? Let's say we have other digits. Let's say A, B, and so on, different digits. So if the units digit is 0, then it means it is 0 into 7 to the power 0 plus A into 7 plus B into 7 square and so on. So if there can be 7 cube and so on. So we see that 7 times of like 7B plus A plus this is 0. Okay. So basically, if the units digit is 0, that means it is divisible by 7. अगर कोई भी बेस नंबर होता है, if the units digit is 0, that means it is divisible by that base. In decimal system, if a number ends in 0, what do we say? It is divisible by 10. So in any base system, if the units digit is 0, in any base system, if units digit is 0, that means the number is divisible by base. So that is the logic here. Okay. So we are finding non-zero. That means not divisible by this. So 500 divided by 7 gives us 71, 7, 49, 10, 71. So 71 numbers are divisible. So they will have, that means 0 as the units digit. Non-zero, how many will be there? 500 minus 71, that is 429 numbers will have non-zero units digit. Okay, so the logic here is if the units digit is 0, the number is divisible by that base. So if the digits, if it is non-zero units digit, that means the number is not divisible by the base. So we will get 429 such numbers. In a certain base n, BC8 to the power n, base n, and this base n is 449 base n. You need to find the value of n. Okay. Now, if alphabets are present in a base system, so what it means is, like if you take A becomes 10, B becomes 11, C becomes 12, and so on. So basically, it is 10, 12, 8. I mean, treat this as digits. Base n minus 7, 7. C is 12. Base n is equal to 449 base n. Now, I told you that we can write it as 8 plus 12n, 10n square, minus 7n square plus 7n plus 12 is equal to 4n square plus 4n plus 9. Okay. So when we solve it, we get 3n square plus 5n minus 4 equals 4n square plus 4n plus 9. So when we take it this side, it becomes n square. This is minus n plus 13 equals 0. Okay. Get this 4n square and minus 3n square is n square. 5n, so minus n, and this is plus 13. Okay. Now, if you look at this, if we solve for n, b is, sorry, b is 11. We made a mistake here. It should be 11, 12, and 8. 7, 7, 12. So this is 11n square. So this is 4n square. Okay. So this will cancel out thankfully, and it will be n is equal to 13. Okay. So the answer is 13. This is the equation method, right? So there are two ways to solve this question. One is by equation method, and another one, which is a smart move and can be done directly, is the carry method. Carry or borrow thing. So see, last digit is 8. 8 minus this digit is 12. 8 minus 12 is 9. Okay. So see this. If you, let's take it in a decimal number system and then you will understand it, this number system. So if I do 3 minus 7, Okay, so if there are some digits present over here, 3 minus 7 is what? See, if there is a smaller digit, what we do is we divide, like, we subtract easily. Like if it was 7 minus 3, you would say 4 easily. But if this digit is larger, so we borrow one digit. Okay. We borrow 10 and becomes 13. 13 minus 7 is 6. So we borrow actually not 1, we borrow 10. That is why it becomes 13. So we always borrow or carry the base. So let's say the base is b. So b plus 8 minus 12 is 9. Or we can say that b plus 8 becomes 21. So b plus 8 is 21. So b is 30. So this is a much easier method than this one to answer the question. Okay. So always remember that when we do subtraction or addition, we borrow the base. If you have to add two numbers, suppose we need to add 449 and 77c. So let's learn both the ways. So we have to add 77c. Okay, and find what is the number that we will get. So 9c is 12. Okay, so 9 plus 12 is 21. So we cannot write 21. So we will write 8. Why 8? Because see, when we add numbers, we carry that extra digit. So here we will not carry 2, we will carry 13 because the base is 13. So we will carry 13. So we will add 1 here. So 4 plus 5, 5 plus 7 is 12. 12 and then we have 4 plus 7 which is 11. 11, 12, 8. So 11 is B, C and 8. So we carry or borrow the base. So if you have to do addition or subtraction in a base system, always remember that you will not carry or borrow 1. You will carry the base of that digit, base of that number system. So here, if it is doing 8 minus C is 9, 8 minus 12 is 9. So we have to borrow the base here. So it should be 21. And in order to make 21, we have to borrow 13. Hence, the base is 13 in this question. So in case you are preparing for CAT and want to learn these concepts in detail, in fact, in all the sections, right, you can enroll in our CAT 2024 batch and you will get to learn not only these concepts, but also you will get practice sheets, doubt resolution group to resolve your doubts, full length and sectional CAT mocks, and GDPI preparation as well. Okay, so this was today's video on number system. So in these two videos, we covered number system in detail. So more videos lined up for the entire month. Please see the schedule and watch these classes daily at 12 p.m. on our channel. And if you have not yet subscribed to our channel, don't forget to subscribe to our channel and recommend to your friends who are preparing for CAT 2024. So thanks again for watching this video. Have a great day. Goodbye.